That was my idea, because otherwise if I just leave it, you face issue. We'll try to see what works the best, doing this mixed exercise time in the theory part as well, or just do just theory and then the leave for the exercises. We'll try to see what works the best, and please let me know what you prefer. Okay, so you were able to run, and some of you have the issue with this running this command in the Windows. Just try to copy this command and find ask what is sort of equivalent of running this in Windows without. There's some issue with the quotation. I am not able to replicate myself, but there's some issue with this. Folks are able to solve this with some quotation marks. Okay, so there was another question. So if you have already like downloaded the code example, instead of creating the code here, if you just download the existing code and try to follow through, you will be able to follow through and be able to run without, because this build plugin is already like I already put in the example code. This build plugin is already there. Then you are able to run this this command directly. So the jar that you created is already has everything inside. And don't try to run this one. This is just to check that that your manifest has all of these. Sorry, the jar has all of this inside this. Or you can actually run to see inside. If you want to look inside what is inside the jar, or other way of looking it is also just so okay. Another way of looking at it is into, let's say you want to look into what this jar looks like. Yeah, so see, it has a manifest file, and that's what actually it was missing earlier in the when we are not having the build plugin. So it was missing inside the manifest. And what this manifest is and how it works and all that, we will learn that in the later part of the course. For now, that should be good enough because it's the first program that we're running. Alright, let's quickly jump to more interesting part. So this was about how to set up the Maven using command lines. And okay, now the next part is let's do it in the IDE. The IDE that I am using is IntelliJ. So let's create this create new project in the IntelliJ. New project. And then say here, so you want to say, hey, I want to create a Maven project. Select Maven archetype, and then say my Maven something like that. Just give name, and then here from the drop down you can actually select the archetype that we just talked about. What type of project that you want to build? You want to build as a web, or you just want to build as a plugin? You want to build as a site? Or you want to build a kickstart, which is just a simple Java or web app or simple site, or the bunch of this archetype, or you could build your own archetype. Let's say, meaning that if you have a specific structure of your project, you can build your own archetype for that as well. So, and it allows you for others to follow the same template. So this is basically a template of how the structuring should look like. Then maybe let's say simple archetype. Just select quick start. Add and then version of the archive that you want to give. You can specify version here and then say create this git, and then say create. So then it has created this project for us, which has of course has the same structure, and hello app, and if you and then within the ID, how many of you are using IntelliJ? And how many of you are using VS Code? Okay. I'm not sure if it looks similar. Maybe I should try to run VS Code as well. But if not, then in the IntelliJ you have the Maven here in the site, and it has all the lifecycle hooks that we just talked about. To clean, validate. So The Maven is already, there is already a Maven plugin, Maven wrapper inside your IntelliJ. But if you say, okay, I want to use the Maven that I installed in my machine, you can actually also do that. So in the settings, you can actually specify which Maven that you want to use. So here, if you go to the build and execution tool, build tools. So in the build tools, we have the Maven, right? In the IntelliJ or the ID that you are using. Just go to the build tool, and inside the Maven, actually you can specify which Maven that you want to use. So if you want to use the Maven that comes like built in with your ID, that's also fine. But in some case you want to specify a custom Maven tool that you want to have full control. You can also do that. Then you need to specify here where your Maven is installed. So let's say in my case, my Maven is here. So I will just specify this part here, and then it would automatically know my Maven version, and then it will apply throughout my project. When I run this all hooks are like, now it's not the Maven that comes with ID, but it's mostly the Maven that we installed. And then you have all the lifecycle hooks. Maven clean. Try to run this. Clean, validate, compile, test, compile, package, install. Try to run that. And try to cite. That generates the documentation for you. And then deploy. So some of you are like kind of asking about the deploy, because that's something you will do a little bit later. This deploy is basically pushes it to your like production server, or your you can also put it in your like component registry, or wherever you want to put. So this is a little bit advanced stage that once we move to the deployment, that's where you are going to use this hook. Alright, so this is how you compile, and maybe you can also run this main file directly in the ID itself, but then it is able to run the code. But under the hood, it is just doing the same thing that we were like doing in the command line application. So it is passing how does this look like, where is the target app, where is the where this file entry point is located. So if you run this ID also does the same thing for you. Alright. So this is how you create in the ID and run the project in the ID. Just quickly do that, and then we just move into. Is there anything else that I need to talk about doing this in ID? So doing this in ID is fairly simple. Let's do it one more time. Maybe quick. Just go to new project, and then generate of Maven archive. Or you could just do the Java type and then add it later on. So this is the configuration stuff, don't get confused. But if you do it properly, then you can use the standard templates. That's the main purpose of doing it via this. Otherwise, you could actually also add this later on, the whole form of XML configuration to your existing project. You can do that later on as well. Yeah, and then just select a particular web. Let's this time select a web app. Give some name and say. So in advanced setting, actually you can also specify the group ID or the artifact ID that you see in the form.xml. All of that you can specify here. This snapshot version you can also change from default. So and say create a new window. Let's see how it looks. So this time it creates a web app which has it's again JSP. No, it uses JSP, but just for an example. So it has a resource folder into it. It will have any sort of things. So it gives you different structure depending on what sort of archetype you choose or what kind of application that you are building. So this is then the form structure is also more or less same. You specify the version ID, the name, artifact ID, and the group ID. This is like kind of packages, that package name that it uses, and then you add the dependency here. Let's say in your application, if you need to use something external library, just add them here, search them in the Maven repository, and just add them here, like just like this. And in the end, you own the you own this your own jar that you just created. This can you can actually specify, if you specify this with the group ID, artifact ID, version ID. If you want to use this this in some other project, you need to specify in the same way. Artifact ID for this is the name, and then version and scope, and then you can use the jar that you created into some other project. That's something we will look into the next example. All right. Any quick question, thoughts, confusion that comes to your mind? Yes. Group ID is to uniquely identify. Is like it's a kind of package name. Package namespace is like a namespace that you give, and then artifact is a unique identifier of that. We do that. So it's like the same package structure that you say form dot da so that's what you use in the group ID. So let's say sorry. Here, this is your group ID. This part, and if you see in your in here in the form.xml, you see this is your group ID, the main that you see here inside. Does it make sense? And this one is to uniquely identify the artifact ID, meaning that this is the component or the piece of sort of plugin, whatever that you're building. That Maven can uniquely identify that. You package basically everything inside. So sort of package name. So simplicity sake. And here instead of jar, you can also specify var or other types that make sense for it. Again, it offers you that flexibility. Cool. So I hope you managed to create the new project. Are you able to create this in the Visual Studio? Those who are at least using the Visual Studio. Okay. Cool. And also able to run it. Run the lifecycle hooks. Okay. Yeah. The hook should probably work the same. Plugins, all of that, the stuff that you have actually in your form, you will be able to see that here. If you have plugins for cleaning, compiling, deploying, installing, all of that should be part of the plugin. And the dependency, so currently we only have one dependency. If you add more dependency, let's quickly add the dependency. Maven, Central, just for anything. Let's say YouTube. Let's say anything that sounds pretty nice. See, if you want, let's say if you want to use a service for doing something with the YouTube, right? Interacting with the YouTube, they have their like dependency YouTube API that you want to include that into your project, right? So just go to the Maven Central and maybe search for the artifact ID, and you should be able to find the same. Let's say Maven Central, search for something that you need. So you get different version of them. So this is a public repository, and then you say I want to use. So there are different version of this available, and then you say so. Let's say I want to use this, and then you say which build tool that you are. So currently we are using Maven. Let's say you want to use the Gradle or any other sort of environment, then it gives you that flexibility to how to install. Let's say if you're using Gradle, you could install via this, or any other frameworks you can also. Since we are using Maven, just say, just copy this and you put it inside your form.xml and then the dependencies and start using it basically. That's a sort of and then say from here you can actually do the Maven install. This should generate the this should do the installation for you. Install and it will download the dependency. See, it has downloaded the dependency which is now available for your application to use. Alright, so and you also see that in the dependencies here. See, this is dependencies that you can also see in the Maven plugin side here as well. Now there is here any other thoughts, questions before we move further? Yes, no? All good? Alright. So let's move to the next part. I think this is much more fun part now. Then the settings. Settings are always something that goes wrong. That you don't plan out. Okay. So we learned how to create the Maven projects in the command line. We learned how to do the set up the Maven in the ID and use that in ID and even in the project. Okay, we talked about the life cycles. Here in Maven, there are a bunch of life cycle hooks that you get to do different type of task automation. Yes, adding dependency that we just saw, we just add the dependency that you need. It's an external dependency, or if you have your own archetype that you want to add, you can add just in the same way as it is the external. And dependencies you could actually add the scope. For this, you could actually add a new tag saying scope, meaning that hey, I want to use this dependency only on the test. I only want to use this in the production. So it's like depending on what scope that you give. Okay, use this jar only for testing, while testing, or use this only jar for all the even for the production. So you can actually also specify the scope for that as well as how the Maven should treat this dependency only for the testing, only for the production, for both. All of that, it gives you that flexibility. Okay, so this was the first exercise that I have that you try and running the Maven project. Most of you have already done this, but still you try to do this at home just one more time to see that you are familiar with the structure and everything. This is a simple exercise where basically you add dependency. And the example that I have here. Yeah, so this is basically how we set up this set up the Maven, add a new dependency. In this case, JSON like converter. It basically converts the weather API and the like sort of things. It's a simple API call that you make to the weather API, and then you parse this and run this code. So this is a simple example. If you want to do something else, please feel free to do that as well. The main purpose of this was just to say that hey, you know how to create the project, how to run them, how to automate the build sort of environment. That's the main task. You should be able to do the Maven compile, should be able to package them, should be able to run them, the jar file, and do the dependency. Like just try to get hold of the different hooks or lifecycle hooks that you have here. So we'll try to see how the Maven site generates the documentation for you. This was the first one exercise that you should try at home. Although you're already familiar with the setup and how to do it. Okay, now let's quickly run through is the pace okay, or is it too fast, or is it something that I should be mindful of? Is the pace okay, or we should go more slow, or is it like everything is out of something really new, or I don't understand anything, anything that comes through? No? Okay, we are good. issues I tried to highlight, but none of them were the one that you faced. There was also a quick learning for me. Okay, so this was a very simple project, but most enterprise level projects, so the complex projects are never like a simple project, right? So there you will have multiple code modules, they depend on different like components, and how do you like put them together, and how do you sort of separate them. Let's say you have a business use case, you have a and you have different business use case. For each business use case you want to have a different package that does a certain type of task, and you want to package them and use it somewhere else. So the real world applications are quite complex, and there you this whole concept of multi-node model projects with the Maven comes really handy. So why to do the multi-modal projects? So typical most in real world projects, you would have to have separation of concern, you have to have dependency management, encapsulations, and inversion of control, also the principle that we will learn a little bit later. Also scalability, and also the efforts to build and run, do the DevOps part, right? This becomes really challenging as your projects grow, and typically you want to build a module, integrate it, build a module, integrate it, and that's how you want to build so that it's loosely coupled, flexible, and like you're able to build. And that's where there's this whole purpose of building a Maven multimodal projects, where each task or subtask that you have is a module, and then you just put them, stitch them together. So, just to demonstrate what I'm talking about, let's say you are building simple calculator app, right? There's nothing fancy, just adding addition of two number. So, for doing this task, you have business use case, which is a sort of addition or the calculator, basically the functionality. That's your business use case, right? So that's a core functionality of your application. So you build a module for core business use case, which is like, let's say, calculation. Then you have application, basically, which consumes this core part and like has a GUI and other stuff. So you have just one business use case. Let's say in this case for calculation, you have calculator core, which does the calculation, has the function for addition, deletion, or multiplication. So this is a big core business use case. And then you have a service layer, a service component, which basically takes the service from which takes the functionality of core and also provides the service to the main application. So you have main application, you have service layer, which sits in the middle of your core components, and then helps your main application to give those services. And why we are building this? To make use, let's say instead of one type of calculator, we want to switch to another type of calculator. Or in this case, the calculator. Let's say you have business use case that is fulfilled in a certain way by certain vendor, but suddenly you have a new vendor that you want to move with, right? In that case, you just keep the core logic to a different business functionality. Here in this case, let's say we are talking about calculator, but it could be a different kind of calculator, let's say scientific calculator or simple calculator. So these are different services, let's say. So if this part changes, the thing in this and this will change. It's like the way the reason of building this in a modular way is like you make changes into one part and then other parts are not affected at all. And then you can build and still compile and run, and it's really powerful in that sense. And that's where this whole idea of separating the core business use case, service layer, and then the application in this example. And all of them being build a separate module, just like in the previous example we have a simple module like that. We will build all of them in separate modules and see how elegant that is in terms of design or like and adhering to all the principles that we just talked about, right? These are the core principles. Whenever you are building an application, that you should adhere to this, because these are this one?
Yeah, the application, that's just basically like kind of I mean, it said it right there, but like I'm imagining like a main method kind of or something.
So the application is main, basically the entry point, and has, let's say, takes care of the GUI or like if in case you have GUI or any other sort of like the main front part of the application. yes, it calls the other component. That's what we are going to see in this example. The idea is that they're loosely coupled, they're placed and they're independent of each other, their build is independent, their compile is independent, and then they are called into other parts and they're easily replaceable. They're not, the code is not really tightly coupled. So that's the main sort of, and that adheres to this easily encapsulation and separation of concerns. Like each one is responsible for its own task and then is easily replaceable by others. And of course, within each core part, each component, the dependencies are managed separately, and not it's like one dependency for everyone, for all the parts. That's why the multimodal projects are really powerful. So again, you have the core part basically has the core domain logic. Don't think of it as a calculator per se, but think of it as a business logic that you have. The core business logic that doesn't change, doesn't affect by anything that you use, the core domain model that you have. And then you have service, and then you have the final one that basically consumes both of these. We'll quickly look into the example, but just want to give you a theoretical sort of know how they look like, and then we jump into the code. Then we will have much more clear understanding. So it's a bit slow. So it's the same form. All other structures of the forms remains the same that we saw previously, but in this case we have a mother form which basically specify all other like the dependencies that your application is going to have. So we have different modules in this. We have the core module, we have service, we have app, and what it does is all these sub-modules will compile, generate their jar independently, and then that jar gets placed into this this mother form, and then it provides the service automatically. So all of those dependency, the independent projects, these all are small projects, let's say, on their own. Like all of these are independent projects, the sub-modules, and all of them will be compiled separately. With the dependencies will be managed separately, and in the end, in the mother form, you are basically configuring them, saying that hey, put them together. My application is using these different modules, and that's the main sort of thing that you will see in the mother form. You need to specify them, and as you are asking about what does each of these do, so the core is like sort of main business logic, then your service layer, service component is like middle layer, that separates the core business from the, and then you have application, which basically consumes everything. Alright, so let's quickly look into, yeah, the calculator is main business logic. Okay, so you have different forms. Each of them have their own form, and then you also have a root form. Like once we look into the example of the code, we will have this more clarity. So you have a mother form. This is the mother form that I was talking about, parent form, whatever. And then each one have their own forms. So let's quickly open this example in Wix Learning, then we dive deep into the code. So quickly jump into calculator app here. Just download this and open it in your IDE. Do that. Alright, so just open this in the IDE. So that's your user. Close everything. Open. So I hope the code is visible in the time. Yeah, so we have this is the sort of root where we have the mother. So everything down so that it looks clean. So this is our mother form, parent form, where like this is a full-fledged application or calculator application, and then we have some modules that we are using in this app, and let's dive deep into. And this is what we are talking about. We just specify those submodules here, and then inside the component, we have different components, and then each one of them have their own form, basically telling how to build, how to consume the dependency in that. It takes care of that, and then one peculiar thing that you would notice is like here we are actually specifying relative path. So that where is the parent form located here, right? So this is a way of telling that where this module fits into the scheme of the big picture of this project. So here we are actually creating these archives and consuming them locally, but in real projects sometimes it happens that you create a submodule, publish it in the central repository, your custom repository, and then others will download it from there, because not everybody have the same sort of setup. So the goal is that you build, just publish that, and then people will consume it from there. But here, since we have full control on all the repository, we just specifying them locally in the form. Instead of this, you could also in the main. Instead of this, you could also just download them in the dependencies here, and that would also be fine. So, but this is a like local way of specifying where the module is. All right, and then let's quickly before we jump, let's quickly. So it's just basically a simple calculator app. There's the addition and subtraction. So this is the main application that runs, and it uses the service, basically calculator service. And this calculator service comes from this project or this component, and then this itself is actually using the core calculator, like where actually the addition and subtractions are taking place. This is a sort of service which basically gets an instance of. This is really a bad way of doing, but this is one of the ways. We will see, like as we move ahead in this course, we'll learn why this is like hard coding. This is a really bad choice, but that's a different concept that we will tackle a little bit later. But for now, just understand how to use the modules in this space. So this is not the recommended way of doing this, because there are a lot of issues with the dependency management, because we are hard coding the object creation, and then that's where the whole concept of dependency injection comes, which we will cover a little bit later. So, but for now, just forget about it. This is where we are consuming the service. So I hope the project structure is clear to everyone. And now let's run this. Right. And then see, when you compile and run this code, it actually creates the dependency reduced form. We basically it tells the whole, like it just within each within the main, basically it generates this whole like form for where we have all the packages. Yeah, let's run this. Clean, so the same way we did it earlier. Download it, go to the particular repository for this. In this case, we are in the parent folder, right? Just run VM clean and oops. Okay, so you know why? See, because I'm running it from the wrong place. So see, this is our project, and I'm inside the application, this one. I should not be running it from here, like the some module. I should be running it from the parent, which is here, which sees this form, right? This is the main the parent form. I should be running it from here, this at this level, then it spins all the other projects together. Since in this case MC, my path is inside inside this application, inside this one, and that's why it is giving there. Let me just quickly go back. So yes, I'm in the parent, and let me run this, and it should run. It's just downloading the dependencies. So yes, so it has compiled and built all the sub sort of projects successfully. So it has created the jar for, if you just log through the messages, you will see that it has created the calculator snapshot. This is the final jar for that is created for this, and similarly it has also created the jar and target classes for each sub project. See, for each sub project you will see that classes. Or maybe just look into. So for each sub project you have the target. See, inside the target you have jar for each of them, right? For each of them inside the target you have the jar. So it's basically creating them as sub modules, and now the jars will be used in the main parent form, and that's how the dependency will be supplied. This might look overcomplicated for simple projects, but as the projects grow and they becomes really it's a life saving basically. Dependency management is a really big challenge if you don't do it properly. Okay. I hope that part is kind of clear. Okay, now let's run this. So now we have compiled this whole thing with package clean, and now for running it, our main entry point is the calculator app, right? Others are just the components that we will consume the main. So we just navigate to this, and now here we basically run the jar. So we have already created the jar. Instead of we will just run this jar, and then it's just, I don't have GUI here. I just have the method. Let's say that I'm doing the addition and subtraction of 5 array, and these are the two functionality that you see here. But it could be any business use case that you feel like appropriate. But I wanted to highlight the main sort of design thinking behind this, how to do the separation of concerns, how to make it modularized, how to do it loosely coupled, and so that it sort of, if I were to change, let's say, this one with something else. Let's say if I were to use different service, the core part, I don't need to touch any other part. I just need to compile this again, and everything will be taken care of. I just replace this calculator app. Let's say this is simple calculator. Instead of this, if I have scientific calculator, everything else will work in the same way. The core part. The core part is, so this is simple one. If I have another some module that does more complex tasks, I don't need to change anything in my sort of position. I just need to link that new core module, and then basically replace this one with that without changing any part of the core in other applications. So, any questions, comments, thoughts before we move into? So this is about modularity, that you could build actually with the modular sub-projects and communication.
You might have explained it before. Just like the jar is kind of just the equivalent of an executable, right?
Yeah, it's an executable that you could run, or you could take service from. It's like archetype basically. If you look into the Java archetype, or that it's like packaging basically. How do you package everything for final? Let's say Java. In Java world, you have jar, you have var. This is the web application. You basically bundle it together in a var, and then you say Java and run it. Then you can run it. It's basically packaging everything together for final execution. Let's say you want to deploy it somewhere, right? On a server. This is what you deploy. That gets deployed. That has everything inside container, inside it.
Yeah, I'm just trying to
Yeah, it's a sort of DLL. Let's say it's sort of DLL. In the Windows space, you have DLL that does something, some particular task for you. It has similar. It's something executable that has its own independence, like like
Right.
yeah. So even though these are independent like the components, they don't have interface, so they don't have UI or anything. They are independent. You can compile them, you can run them independently of, let's say, main application. So they have their own independent life cycle. There is full-fledged component in themselves, right? As a core functionality. Yes. It's a way of packaging basically. That's what you get, and which can be executed anywhere in the JVM space. Yeah. All right. Any other thoughts, comments, confusion before we move further? I think I have somewhat more, few more slides, and then we are good.
What about code security?
Code security.
Because from what I know, the jar pretty much exposes everything inside. Because like we can open it with WinRAR or anything, or does it do
No.
something?
It depends on how you like. Does it expose anything? Everything. It depends on how you are like using those private, protected, and all of that. The access modifier. You could actually restrict that nobody sees that. Or you are talking about the inside, like looking inside the jar itself.
Inside the jar itself, as in
Of course, you will have a bytecode, executable bytecode there, for sure.
So it's just the bytecode. There are no like additional metadata.
No. It's just all you have is machine executable code. Of course, you can do the reverse engineering from machine executable code as well, in that sense. And you could do that with everybody. It's not just specific to Java. But yeah, no security is not sort of mean. Of course, the access modifier that you have, that they could expose, like let's say, the functionality that should not be accessible outside. They can be made accessible if you don't use access modifier properly.
I mean, code-wise, yeah. I just wanted to know about like the reverse engineering part.
Yeah, the reverse engineering you could do with any code. So all you have is Java executable code. Even if your machine, let's say, even if you don't have the byte executable code, if you have assembly level code, you could also start doing the reverse engineering from assembly level up as well. Like that, you could do with any programming language. Okay. And that's what hackers mostly do. Okay. So the main thing that we just talked about here is this it's called componentized approach of building this piece of software. Is that it adheres to encapsulation, that each has its own like core logic, its own functionality. It has the abstraction nicely. You have the modularity, and most importantly, you have the principle of reusability. Right? These components can be reusable by others as well, like not just your application but by others, or even within your application you make them reusable. Abstraction, separation of concern. You have separation of concern, which is like, okay, putting different things in application, business logic, the service layer, the application layer, you just try to pull them apart. Replaceability, of course, the components are replaceable without like affecting other parts of the code. So this, in a way that the principles of component-based system that we talked about, they sort of adhere to this design philosophy. Okay, next, a beautiful example where you can really appreciate this whole multi-modal approach is an asteroid collision game that I have, where you build this asteroid collision game where basically some asteroids are coming, you have a ship, and then they interact with each other. That's a simple sort of game. But again, the game is not important. What is more important is that the way of constructing this. So I have two implementations. Example one is inheritance based. Another is component based design. So in first case, you build this game using simple inheritance that you have been following so far, have been most familiar with. Then you do the same with the component based approach, and in the end you need to modify something. That's an assignment that you need to do. Okay, you build this game. Now your task is to add maybe a new functionality, a new feature to this asteroid game, and then see if you just do the inheritance way of what are the pain points, and if you do it in the component way, it's how neat and clean and replaceable it is. That's where you will be able to see the beauty of the proper design. So this is this game all about. So first one is inheritance-based design. That okay. Before I maybe talk about it, let's quickly jump to the example, download the example, and or should we download it in the end? Okay, let me just explain it at the basic setup, then you can download the code. So basically, in first instance, we have the inheritance-based design of this asteroid collision game, where you have the focus is class hierarchy. You have the game object, you have the asteroid, you have the ships, and then they have the different attributes: health, speed, and weapon system. And asteroid has its size and shapes and color and all that. And your base class object itself has a velocity, position, and collision detection. That's main sort of part of the main base class, or which is called game object class. In this design, basically, it follows a hierarchy. All of these will actually inherit the base object, and then they will build the functionality. But the problem is with this class would be if you need to change anything, it's just really messy. You'll appreciate it once you look into the code. It's very non-flexible. Compared to that, we will build this in component-based approach, where we have all these core functionality. Let's say position, velocity, collision system. These all are componentized, and you could think of new features that you want to add in the existing game. You will build a new component for them for that, and this sort of offers you a lot of flexibility of doing the same thing in a really neat and clean way, and avoid the inheritance mess that you will see. Okay. Now let's before I talk about take home test, let's quickly look into the example. I will quickly show you how they just download both of these examples, inheritance based, and then also the game based, the component based. We'll quickly follow through the code for both of them, and then the assignment for you would be to make those changes, and in each of the score based, and it could be anything like a new functionality, new feature. There's a very small feature that you think is interesting to you, and see the main takeaway or the main thing that you should focus on is how difficult it is to change. Alright, so let's quickly jump to the code. I open these projects side by side, so it's easy to. By the way, try to run the calculator example on your own, and let me know if you have any issue later on. We're not going to run that here in the class to save us some time. Open, just close it. Open, and then this one is I'm opening the component based implementation of the same component based game. New window. Okay. Okay, let me just place them side by side. Alright, so see, so this is how the inheritance base looks like. Everything inherits the base class. So I think this is a better way. Everything inherits from the base. So yeah. So basically the game object inherits the common game object class, and string is like a framework that used for GUI, and then you have event handling for movement and actions for the ships basically. You run, let's see how it looks. Compile. jar, you just need to go to the main file and then run it. So this is how it looks. This is basically the asteroids are coming. This is your ship, and it's supposed to like see the collision in there. If there is any collision,
Yeah, you also can't move.
you can move them left, right, and center. I think.
No,
No.
that's what I'm saying. You can't. It does put into the terminal that you're both shooting and moving left, but the right key doesn't work and none of it registers on the screen.
Not understood. Yeah, because the movement is small. If you increase the movement in the core, like the left key, how much it is moving. Of course, we are not going to, again, the goal here is not to go in the technicality of game design itself, because that's, again, it could be an interesting discussion and also a thing about, because the game design are really, really complex logic. Here, the main thing that we are discussing about the design itself and not the game logic. So business use case is not our main focus. It's the how do you like structure this in a way that it's easy to modify, easy to change, it's easy to replace and all that stuff. That's sort of that you should focus on. Of course, you could do a lot of complex thing in the game design. So don't get lost in terms of the business use case here. The business use case is not the focus thing. Focus is the design. That's what you should again keep in mind while discussing this example. So yeah, you have to estimate there is a speed. You can trace the left key. See, it is moving, but see, the movement is very negligible, and that's why you are like sort of not able to. Of course, you can make it perfect. I'm not. That was not my intention to build a perfect game. But the idea was that hey, we have this game, and if you want to make any changes, how easy it to to make the changes in a certain way. If you do design this game in a certain way. So this is inheritance based, and if you look into any of the small ships, see the ship class is basically extending the game object, and similarly the asteroid. Where is the asteroid? Here we go. It also inherits the game object, and that's sort of intertwined. And as compared to this, let's also look into the component based design. So here we have the common, we have the entities, we have the runner. This is the runner is basically the final the GUI part of this application, but other core features like the core functionality, the common functionality that you see in the objects are separate and each built into different components. And then in the game entity you have the asteroid and ships. So these are the game entity. Imagine if you want to introduce a new game entity, a new player, something like, then you just add it here and this will reflect in across all other parts. So it's very easy to sort of change. And then in the runner basically you say this is your entry point. In the application you have the game panel, the GUI that you see, it comes from here, and then you have the game system basically which detects does the collision detection system, and you have movement system. So you have them as separate like sort of use case. You put them like into the game system. So if you have a new logic into the game system that you put here, new feature that you want to put, you put in the common sort of that feature that has is across the different the objects that you have in the game. So in this way it's easy. So let's run this. This is inside the game runner. That's why. So always remember that you need to run the maven clean inside the root, inside the parent. That's when it will compile everything. If you want to compile individual project, then you go into the individual like subdirectory and then compile them here. But if you want to compile all of them together, then you need to go into the root of the root form, the parent form basically. Like for all of them, this is the parent form, right? Where you have similar to the multimodal example that we earlier saw?
Good question. Could you maybe run us through an example of like, because you like told us before how to, for example, um, exchange like an entire component. What I was thinking right now is, for example, let's say we have like three entities right now. Like, let's say we want to add a poll from like how would that work? Like, what would need to happen to like for the entire application to work in that instance?
Yes, that's an assignment that you would do. That you need to add a new component. Let's say add a new player, for example. You have asteroid, you have starship. You want to add a new player. That's it. And that's that you add. Or you want to add a new system. Let's say you have game system. You have new instead of collision detection and detecting the logic for collision is one entity in the system. Or you have movement like tracking. You know the system left, right, and up and down. Similarly, you could imagine any new thing that you have for the game, any new feature that you have to add. Maybe you have a feature. That's I think what I have in the example is like you have the asteroid, a new asteroid instead of this existing asteroid, a new type of asteroid is coming that blinks for 5 seconds and then just disappears. How would you do that?
My question at this point would be, maybe you don't want to answer this at this point, but like.
How would you do that?
No, rather, well, kind of. So let's say like we want to not like change the entire component, but only part of the component. Does that mean we have to still like exchange the entire component, or can we just take a part of it?
So if you let's say for example out of these 4 or 5, like 4, if you just change add the new features to this and then compile this and make it available to whatever like all of these are using, which one of these is using, then you're good. That's the main part. You need to only compile this and not everything, recompile everything, and it should work. If the design is clear, if you mess up with the design, intertwine, like you use some features in not including, and that's the problem with the previous example, the inheritance space. If you want to make any changes, you need to make changes all over. That's some sort of main takeaway of this. And so similarly to the multimodal objects, here you see all of these are some parts added into the parent form. Parent form has some issue, and this is because of in the XML. So I'll just go to. So there is issue with the parent form. Of course, it doesn't affect you. You can still run the code, but it's just XML schemas. Sorry, the XML schema that has this issue. I just replace it with the new one. That is another, so this error will disappear. Okay. So earlier I was running this inside the game runner. Just move back. Sorry, I did the cd command here. The error has disappeared. Okay. So let's run this inside the. I go back. So yeah, and now I'm into the parent or the like the root folder, which I have my parent form, and then I say clean install. Yeah, everything compiles. All those components are compiled, and then the game runner jar is created for us that we can run using. Yeah, you can run this jar itself, or if you just want to say, I just want to run the main file within this runner, like that's application, the main application, which is this one, right? If you just want to directly run this should also be fine. So it's different way of running this. You won't get confused with this. So let's say I run this with the from the ID directly instead of doing the command line. It runs and the moment it collides, it adds the collision detected. So this is again the simple example. I run this again. So these are 2 asteroids that they collided earlier, and this is the ship. Small this object. Of course, don't get confused with the shape, but yeah, this is the ship that doesn't move. They are coming and they are colliding. Of course, you can make it more than change the shape and size by tinkering with the code. Okay, so now, and the main thing that I wanted to highlight is that you could do it in a really clean way, following this approach. And then the take-home assignment for you is, let's not try here. Try doing this, and if you cannot do it, we'll discuss it in the next class. But this is a really good stimulation for you to start thinking about in terms of the architecture or system complexity if you just don't do it like designing in the right way. So I have an assignment for this. It's essentially same thing that I just talked about. You need to change, basically add it, let's say when asteroid is coming, visibility, just change, just do something with the visibility and make it blink for some time. Or if you don't want to do this, if you are inspired to do something else, just do something else as well. But the main thing that you should be observant is that how easy or difficult it is to make that change given this the architecture choice that you are making. Right. So that's the main sort of takeaway. So, but if you are inspired to do this the exact same thing, then just do this. Okay. I hope this assignment is kind of clear to everyone. Yes? No? Okay. Any thoughts, comments before we move to another interesting part? Or should we? I think we should take a break. It's quite a while. We should take a break. Sorry for that. It's quite a long. We take a quick break, and then I think I'm done. More or less done. Just one more example of component thinking in Java. This is just to start with how we start in terms of thinking of in terms of